Well, for question 5, we have two expressions to factor. For A, we have to factor 15k cubed minus 24k squared. So the first thing we'll do is write 15 in terms of 3 times 5, and k cubed in terms of x, or k squared. So that's going to be k times k squared. And we'll factor 24, and 24 is 3 times 8. And k squared remains k squared. Now, you can notice that 3 is a common factor of each term, and k squared is a common factor of each term, so we'll factor those out, install parentheses, and what remains in this term after removing the 3 and the k squared is 5k. And what remains in this term after removing the 3 and the k squared, it's 8. And notice, we don't have to factor 8 any farther. We could write that as 2 cubed, but 5 and 8 are relatively prime. They have no common factors, so this is very acceptable. And we're done. We've factored what we were given. For B, we have 4 terms, 3m squared plus 3mn plus 12m plus 12n. And the first step is to always factor out any common factor that exists in each term in the expression. Well, 3 is a common factor of every one of these terms. So we're going to start by factoring a 3 out of those terms, and we get 3 times what is 3m squared? Well, that's just going to be m squared. 3 times what is 3mn? Well, that's going to be mn. 3 times what is 12? Well, that's 4, and we still have a factor of m. 3 times what is 12n? And 3 times 4 is 12, and we still have this factor n. Now, anytime you have 4 terms, think of this grouping. And we'll break these 4 terms up into 2 groups. So we get 3 times, and I'll put parentheses around the m squared and the mn, plus, and we'll put parentheses around the 4m plus 4n. So, now, look at these 2 terms. We can factor an m out of each of those, and we'll be left with m times the quantity m plus n. And if we factor a 4 out of each of these terms, 4 times what is 4m? Well, we need a factor of m here, plus 4 times what is 4n? We need a factor of n there. Now, m plus n is a factor of each of these terms. So outside we have this 3. We can dispense with these square brackets. And we're going to have 3 times, and since m plus n is a factor of each of those terms, we've installed that factor. What remains here in this term is the factor m, which has been unaccounted for, plus what remains of this term? Well, the 4 remains. It's unaccounted for. Now we've accounted for it. So the product of these 3 terms will give us what we started with. And so this is factor by grouping, and we are done. Well, our final task is to find the area of the shaded region in this rectangle. So the process is to find the area of the large rectangle and from it subtract the area of the smaller rectangle. So the area of the large rectangle is 9x times x plus 4. And from it we're going to subtract the area of the smaller rectangle, and that area is length times width, which is 3x times x. And there's our area. And that equals, multiplying through by 9x, we get 9x squared plus 4 times 9 is 36x minus, and 3x times x is 3x squared. Now, combining like terms, we have a 9x squared minus 3x squared, which will give us 6x squared plus 36x. Now, as you well know, we can factor a 6 out of each of these terms and an x out of each of these terms. So that's going to be 6x. And 6x times what is 6x squared? Well, the remaining factor will be x plus 6 times 6 is 36, and the x is already accounted for. And there we have the area of our shaded region, and we are done.